let's take a look at using the identity property. First, let's talk about multiplication. So the identity property is if you have a number or factor and multiply it by 1, you get that same factor back or number back. So that's the identity property. If you have 5 and you multiply it times 1, you get 5. Notice that I used a dot when I have a variable, but you can use a dot or the multiplication sign when I'm using numbers. Another example would be 26 times 1, which would be 26. Or another interpretation of that would be if I have 26 groups of 1, I would have 26 total. Or if I had one group of 26, I would still have 26 total. An application of this is in 3rd, 4th, and 5th grade when we want to find equivalent fractions. So if I start with 1/2 and I want to find an equivalent fraction, and equivalent means they are equal, I know that if I multiply 1/2 by 1, I will get something that is equal. So I'm going to multiply 1/2 by 1, but my 1 can be in any form. So the form I'm going to use is 2/2 because 2/2 is the same as 1. So if I multiply 1/2 by 2/2, I get 2/4. So 1/2 is equal to 2/4. That's how I get equivalent fractions. Another example would be 3/8 times 3/3. 3/3 is the same as 1. That would be 9/24. So we have not changed the value of 3/8. We've simply multiplied it by 1, and that is the identity property. So 9/24 is the same as 3/8. That is really important for our students to recognize as they begin finding equivalent fractions. So the identity property of addition is if I have any number or addend and I add 0 to it, I will get a sum of that same addend. A big, huge misuse of the addition property is when students are multiplying times 10 and they say the answer is 14. So I have 14 multiplied by 10 and you just add a 0. If I add a 0 to anything, I get that thing back. And so I know that 14 multiplied by 10 does not equal 14 plus 0. So it's important that students know the difference between adding a 0 and putting a 0 on the end or attaching it. And even at some point, it is probably not a good idea to use that because it leads to later misinterpretations. For example, when they start multiplying decimal numbers and they have 25 1/100ths multiplied by 10, that does not equal 250 1,000ths. You can't just put a 0 or attach a 0 because those things are not the same. As a matter of fact, it is always better to stick with the place value interpretation of what's happening when they multiply by 10. So here's a simple place value chart, and if I put the number 14 into the place value chart, I know I have 1 10 and 4 ones. And if I multiply 14 by 10, I know that as I move to the left on the place value chart, I am multiplying times 10. So as I move to the left, I am multiplying times 10. So really what I'm doing is moving the number 14 over to the left one place. And so that would create the 140, and the 0 becomes a placeholder in the ones place and not an adding of 0. Again, if I go back to my decimal example of 25 1/100ths, would look like this in the place value chart. And if I multiply times 10, again, as I go left, I am multiplying times 10. And so 25/100ths multiplied by 10 would move that number over one place. Because I'm only going one place times 10, and it becomes 2 5/10. Notice that we don't need the placeholder 0 in that problem. So that is using the identity property and some applications for you to think about and make more explicit in your classroom.